Welcome to doassignment-ca. Here's the problem. An airplane starts from rest, travels 5,000 feet down a runway, and after uniform acceleration takes off with a speed of 162 miles per hour. It then climbs in a straight line with a uniform acceleration of 3 feet per second squared until it reaches a constant speed of 220 miles per hour. Draw the S versus T, V versus T, and A versus T graphs that describe the motion. Now, let us work through the solution step by step. First, convert both speeds from miles per hour to feet per second using the factor 22/15. Multiplying 162 miles per hour gives a takeoff speed of 237.6 feet per second, and multiplying 220 miles per hour gives a cruising speed of approximately 322.67 feet per second. During Phase 1 on the runway, the plane starts from rest and accelerates uniformly over 5,000 feet. Using the kinematic equation v squared equals 2a times s, the runway acceleration is found to be approximately 5.645 feet per second squared. Dividing the takeoff speed by the runway acceleration gives a runway time of approximately 42.09 seconds. Substituting back into the position equation, 1/2 a t squared confirms the distance is 5,000 feet, verifying the result. In Phase 2, the airplane climbs with a constant acceleration of 3 feet per second squared, going from the takeoff speed of 237.6 feet per second up to the cruising speed of 322.67 feet per second. The elapsed time is the speed difference divided by the acceleration, giving approximately 28.36 seconds. Phase 2 therefore ends at a total time of 70.45 seconds. The distance covered during the climb is found using the kinematic equation, S equals V naught times T plus 1/2 a t squared. This gives 6737.1 plus 206.8, which is approximately 7944 feet. Once the airplane reaches its cruising speed, the acceleration drops to 0. The total distance already covered is 5,000 plus 7,944, which is 12,944 feet. The position then increases linearly at a constant rate of 322.67 feet per second. Here is a summary of all three phases. Phase 1 on the runway runs from 0 to 42.09 seconds with an acceleration of 5.645 feet per second squared, covering 5,000 feet. Phase 2 climbing runs from 42.9 to 70.45 seconds with an acceleration of 3 feet per second squared, covering an additional 7,944 feet to reach 12,944 feet. Phase 3 cruising begins at 70.45 seconds with 0 acceleration. The acceleration versus time graph has 3 flat horizontal segments. It starts at 5.645 feet per second squared during the runway roll, drops abruptly to 3 feet per second squared at liftoff, and then drops to 0 once the airplane reaches cruising speed. The velocity versus time graph is piecewise linear. It rises steeply from 0 during the runway phase, continues rising with a gentler slope during the climb, then becomes a horizontal line once the airplane cruises at constant speed. The velocity itself is continuous throughout. The position versus time graph consists of 2 upward curving parabolas followed by a straight line. The curvature is steeper during the runway phase and gentler during the climb, reflecting the higher and lower accelerations respectively. Once the airplane cruises, the graph becomes a straight line. The slope, representing velocity, is continuous at every transition point even though the curvature changes abruptly. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.